Hello, my name is Mark. Welcome to my channel. This should be part 8 of Power Supply Current Saver, proof it's feasible. In this experiment, I use 2 capacitors, 6 microfarads, good for up to 450 volts, as a AC voltage divider. And they're connected in series here. Here's a look at one here. Now, to begin with here, from the wall, I'm connected to a 10-to-1 step-down transformer that steps down from 125 volts to about 15 volts. Then I make the 2 parallel branches. This white wire goes over here, and this is a straight through parallel branch of diagram 3. And this goes to this transformer, which isolates the 2 parallel branches. And this wire here joins the 2 branches together in series, and what causes voltage to double to 30 volts. So there's 30 volts available here to these capacitors, and this is connected to the load devices, which are 2 12-volt light bulbs meant for automotive dashboard for a car back in the 70s, I believe. Now the downside of this experiment is that I have to have 2 devices hooked up. The load can't have one. I tried it, and I tried to connect them in series. There's no other way to do it. So the devices have to be the same make and model, at the same settings. But I really had a good breakthrough with this last night, because when I tested it, it saves almost 70% on electricity. Now just let you have a look at diagram 3 here. And those 2 resistors there are being replaced by the capacitors as voltage dividers. Now here's diagram 8. Those 2 transistors are being replaced by the capacitors. But I cannot, the capacitors don't act like the transformers, which are isolated. The primary coils are isolated from the secondary coils, so I can't connect them in parallel to the load device. One load device. I have to have 2 connected. So there's 2 parallel branches coming from the voltage divider capacitors. One branch there and one branch there. Okay, so now I'll turn it on. And we'll test the current. There, both light bulbs are on. And we can test the current. And this wire here will test the same current as these wires down here. So I can just put it on here, more convenient. and it should measure 0.2223 or 200. Oh, it goes up to 2.4. Well, yesterday it went up to 2.3, so we'll stick to 2.3, but 2.4 is even better. So that's 230 milliamps. Now down here, coming out of the wall, it says 0.09.1. Oh, what's going on here? There it is, down 0.07. That's what I had yesterday. 7.6. Okay, so it's working. So I calculated with the proportion formula here, 0.07 over 0.23 equals x over 100. So 30.4 equals x, which means that 0.07 is 30.4% of 0.23. So 100 minus 30.4 equals 69.6%, approximately 2/3. It saves on current, electricity. So it's very, 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 very good. I was expecting about 50%, but it's almost 70%. So I'm very happy with that, except a bit of a problem here, having two devices. I was hoping to run only one. So what I'll do is experiment, hook this up the same way, but without the capacitors, and we'll just check how much current goes through these light bulbs, so I can determine what's exactly going on here. And when I work with higher voltages, I hope it mounts to the same thing too, because it'll be really good for 1500 watt heaters or air conditioners. But I'll need a bigger transformer here. Okay, I guess that's all I want to say about that. Until later, thank you. Thanks for watching. Bye.